science video lesson. Now, let us have a quick recap of the previous two lessons. In the first lesson, we studied about magnetic effect of electric current. In magnetic effect of electric current, the main thing what we studied is electric motor. The principle of electric motor is a current carrying conductor in a magnetic field experiences a mechanical force. This is called the principle of electric motor. I repeat, a current carrying conductor in a magnetic field experiences a mechanical force. So due to this force, the conductor moves. If the conductor is mounted in such a way that it can rotate, then it will rotate. This is the principle of electric motor. So construction and working of electric motor you studied in detail. Uses of electric motor, you are familiar with all the electric machines where there is spinning, rotation or sliding. Then such electric machines sure to have electric motors. In the second class, we discussed electromagnetic induction. What is electromagnetic induction? If the magnetic field linked with the conductor changes, an EMF, electromotive force, is induced in the conductor. If the magnetic field associated with the conductor changes, an EMF is induced in the conductor. This is called electromagnetic induction. Michael Faraday formulated two laws of electromagnetic induction. The first law is changing magnetic field associated with the conductor induces an EMF in the conductor. That is the first law. A changing magnetic field associated with the conductor induces an EMF in the conductor. Second law states that the induced EMF is directly proportional to the rate of change of magnetic field associated with the conductor. The induced EMF is directly proportional to the rate of change of magnetic field associated with the conductor. What do you mean by this? Rate of change of magnetic field associated with the conductor. Rate of change. That means to say, if the magnetic field increases with reference to the conductor, then the induced EMF increases. If the magnetic field, if the change in magnetic field decreases, then the induced EMF associated with the conductor also decreases. So, induced EMF is directly proportional to the rate of change of magnetic field associated with the conductor. So these are the two laws of electromagnetic induction. So experimental evidences show that if the number of turns of the conductor, the coil increases, the induced EMF increases. If the strength of the magnet, or else if you increases the magnetic field, then the induced EMF in the conductor increases. If the diameter of the conductor coil decreases, decreases, then the strength of the induced EMF increases. So induced EMF depends on the number of turns of the conductor coil. Next point is the strength of the magnetic field. Then third point is the diameter of the coil. So these are the things we discussed in the second lesson, electromagnetic induction. What for a dynamo is used? We are talking about alternating current dynamo. Alternating current dynamo is used to generate electricity in large scale generation of electricity. We say AC, alternating current. So large scale generation of alternating current is done using AC generator. So these are the points we discussed in the previous class. Now in this class we will discuss about electricity transmission and domestic electric circuit. Children, we will come back to electricity transmission from the generating station, from the electricity generating station, how the electric current is transmitted to the receiving station, and from there how it is distributed to the end users, residential layouts, industries, commercial establishments, etc. In the generating station, instead of single coil in the generator, usually 3 coils will be used. So a generator, alternating current generator in the generating station, large generators will use 3 coils, not single coil, 3 coils wound on the same armature. 3 coils wound on the same armature, and one end of the 3 coils is connected and it is grounded. So it is like this. Now children, look here. These are the 3 coils of the large scale alternating current generator. This is coil 1, this is coil 2, and this is coil 3. Common end of the 3 coils is grounded. It's grounded. The other 3 terminals, one is L1, L2 and L3. So if you observe the electricity transmission line from the generating station, you can see L1, L2 and L3, 3 wires, high-rise transmission line. You can see 3 wires coming from the generating station to the distribution station. This is called 3-phase. These 3 lines, line 1, line 2, line 3. The common point is grounded, so the electric potential here it is 0. Here it is 0. The potential here it is 0 volt. L1, L2 and L3 will have potential, electric potential depending on the generator. Depending on the generator. It may be say about 1000 volts or 11,000 volts or like that. It depends. These 3 phase lines are drawn from the generating station to the receiving station. In the receiving station, the voltage is stepped up or stepped down depending on the requirement and distributed to the end users such as domestic layouts, industries and business establishments. You understand? So if you see the transmission line, you see 4 wires. In the residential layouts, you can see the transmission line. You see 1, 2, 3, 4 wires. But whereas in the transmission line from generating station to receiving station, you see 3 wires. The common point is grounded, so the potential here in the ground, when the common point is grounded, the potential becomes 0. So ground has potential 0 and the 3 lines L1, L2 and L3, these are called line wires or phases, 3 phases have potential, electric potential depending on the generator or requirement. Okay. Now if you observe the distribution areas in the residential layouts or industries or commercial establishments, the transmission line contain 4 wires. So which are the 4 wires? Line 1, line 2, line 3 and 1 neutral. One of the wires is neutral, the other 3 are line wires. How do you locate the neutral wire and the line wires? So you just go around in your layout, in your area and locate a transformer. If you carefully observe the transformer and the transmission wires, one side of the transformer you can see only 3 wires. These are the 3 wires, L1, L2 and L3, line wires. The other side you see all the 4 wires. So one of the 4 wires is neutral wire. And if you observe the transformer and that the poles and the whole thing properly, you can see one of the wire is drawn from the earth. See, in the generating station, one wire is grounded. Same wire is drawn from the earth near the transformer. So the potential between neutral and one of the line in the domestic area, residential area or business establishments or commercial area, the potential difference between neutral and one of the line wire is 220 volts. Between these two it is 220 volts. Between these two it is 220 volts. So the potential difference between the neutral and one of the line wire is 220 volts. Children, the potential difference of domestic electric circuit. The potential difference of domestic electric circuit is 220 volts. And if you observe the transmission line near your house, you can see from the 4 wires, 2 wires are tapped to your building. 2 wires are tapped to your building. You got it? So the potential difference is 220 volts. Okay. So this is how electricity is generated and transmitted to the respective application, respective areas, industrial, commercial or residential areas. For industries, the 3 phases L1, L2, L3 and neutral, all the 4 wires are used. That means the 3 wires such a way that the potential difference becomes 440 volts. The potential difference between neutral and the three phase becomes 440 volts. The wires are coupled in such a way, the potential difference becomes 440 volts for industrial purposes. To run huge machines, the potential difference is 440 volts. For domestic purpose, domestic applications, we take one live and one neutral wire, and the potential difference between live and neutral is 220 volts. So how to locate? So assume that you have not seen the transformer, but you have the transmission line consisting of 4 wires. How to locate the neutral wire? If you carefully observe the 4 wires, neutral wire will be slightly thin when compared to rest of the 3 wires. The phase wires are slightly thicker than the neutral wire. So it is easy to locate the wires just examining. By physical examining you can find the neutral wire. Okay. Now we are going to study in detail how the domestic wiring is done, how the domestic circuit is made. Dear children, this is the schematic diagram of domestic electric circuit. You see here is the electric pole near your house. Okay, you can see 4 wires here, 1, 2, 3, 4, and this is the neutral wire. These 3 are the live wires. One of the live wire and the neutral wire is connected, is drawn to your house. Okay, so the 2 wires come to the meter board. This is the meter board or meter box. Okay, wherein the live wire straight away comes to the fuse, electric fuse. Thereafter, both the wires are drawn to the electric meter. From there to the distribution box. This distribution box usually it will be inside the house. Meter and fuse cutout will be outside the house on the wall. You would have seen that. From there, from the distribution box, what is this distribution box? Say for example, your house has so many rooms or so many floors. So circuits will be divided. Say for example, the living room and the bedrooms will be given one circuit, and the kitchen and some other rooms, garage will be given another circuit. The first floor will be given another circuit. You understand? So how the circuit is, the power is divided. Say for example, for the first floor there is separate live and neutral wire. For the bedroom and the hall, one circuit will be made like this. You have separate live and neutral wire running through the wall or through the pipes there. So similarly, different circuits are made. So the distribution box is used for that purpose, to divide different circuits. Okay. From the distribution box, see, I have taken a simple diagram wherein you have a 3-pin socket. You might have seen it. In your house, you see so many 3-pin or 5-pin sockets. Then a fan is connected. Then a TV, very inseparable part in the domestic use. Okay, TV is a must everywhere. So TV, how it is connected, you see. The 3-pin socket, this is the red colored wire is live wire, you see. Live wire is connected to this point, neutral is connected to this point, and the third point is the earth point, ground we say, ground or earth. Next you have a fan. So live wire is trapped through a switch. Here also you have a switch for the socket. Through a switch, neutral is connected to the fan, and spinning. Same way, the TV, the line is connected to the TV through a switch and the neutral is directly connected. This is how the connections are made. This is a simple schematic wiring or electric circuit. You can keep on adding various other like lamps, tube lights, bulbs, okay, whatever gadgets you want you can add. Now, depending on the use of current, the amount of current used for various devices, circuits are again divided from the distribution box. Say for example, in the kitchen, we make use of high current drawing devices like a microwave oven. In the washroom or in the toilet, we use a water heater called a geyser. In the kitchen, we make use of a mixer grinder or a wet grinder and other machineries. We also use a washing machine. These devices draw more current from the circuit. So, such machines are connected to a separate circuit. Low current drawing devices like a fan, TV, ordinary bulb, you understand? These are connected to a different circuit. So there are two types of circuits in domestic electric circuit. The low current consuming appliances are connected to a separate circuit called lighting circuit. Lighting circuit. The device is connected to less current. Understand? Less than 5 ampere. Lighting circuit. Less than 5 ampere current. So devices drawing less than 5 ampere current are connected to the lighting circuit. Devices such as washing machine, microwave oven, your toaster grill, OTG, toaster cum grill, OTG, or your electric iron, electric press, the machines which draw heavy current, more current, say up to 16 amperes of current or even more, are connected to a separate circuit called the heating circuit. So heating circuit, the devices say more than 10 amperes of current. So for example, roughly, okay. So devices which draw, or else I will tell you, let it be more than 5 amperes of current. Those devices which draw less than 5 amperes of current are connected to the lighting circuit. The devices which draw more than 5 amperes of current are connected to the heating circuit. So two circuits. Usually you will have lighting and heating circuits separated in the domestic wiring. Now come to lighting circuit. In the case of lighting circuit, thin wires, say for example 2.5 square mm, square mm thick wire is used for lighting circuit. For heating circuit, 4 millimeter square for heating circuit, thinner wire is used for lighting circuit. Why this gradation, this change, this difference? Lighting circuit draw less current from the mains. So, you know, heating effect of electric current. If more current is drawn, if more current flows through the circuit, more heat is developed. So, heat developed sometimes make the insulation of the wire melt and the whole circuit get destroyed. So, for lighting circuit, 2.5 square mm thick wire is used. For heating circuit, 4 square mm or more thick wire is used. So this is how the two circuits are made in the domestic wire. Okay, why thick wire is used in heating circuit? Thick wire allows more current through it without causing much heating effect. More current can flow easily through the thick wire. Why don't you use 4 square mm thick wire for the lighting circuit? You can use, but it is a waste of money. It is a waste of money. It's not required. So if you use thick wire for lighting circuit, no problem. But only thing you will be spending more on the wiring. Understand? So this is how the wires are chosen for the circuit. Now, if you observe this diagram, you can see a third wire, earth wire. What for it is used. Now, here in the diagram, the meter box is grounded. Meter box is, if the meter box is having a metallic cabinet, if the outer body of the meter box is made of metal, then it is ground. The 3-pin socket, the top pin is grounded, it is connected to the ground wire. If you use a microwave or electrical heavy current drawing devices like mixer grinder, your wet grinder, microwave, washing machine, electric geyser, all these devices draw more current, and most often these devices contain metallic outer body. So for example, the OTG or microwave oven, the refrigerator you see, washing machine, the body is of metal. So in such case, the outer metallic body of the electric device, electric appliances are grounded again. You understand? So for that purpose, the ground wire runs through the whole circuit. Now what is the use of this ground wire in an electric circuit? Assume that your OTG or microwave oven is faulty. There is some fault in the machine, it works, but still there is some fault. If you touch the body of the microwave oven, it gives you a shock. You feel it, there is some shock. You get some electric shock, you can feel it. So it is not that good to get electric shock very often. Sometimes the shock may be severe also. So in order to pass the leakage current, the machine is faulty and there is some leakage. In order to pass the leakage current easily to the ground, you need to provide a low resistance path for the leakage current. If the current passes to the ground through your body, that is called an electric shock. If the shock is severe, you may die also. So for the easy passage of the leakage current to the ground, a low resistance path is provided, that is the ground wire. a low resistance path is provided, that is called the ground wire. So any machine which has a metallic body, even in the case of plastic body also, if the machine is drawing more current, then the ground wire is connected to that machine. And if you examine the power cord of such machines, you can see a 3-pin plug. 3-pin plug. So 3-pin plug means the machine is connected to the earth through the ground wire, and such machines usually draw more than 5 amperes of current from the AC mains. So these are the things you have to understand here. So ground wire is provided for the easy passage of leakage current to the ground. If sometimes machines, even your ceiling fan sometimes leaks, but since it is at a height, we won't be touching it. You understand? But your table fan or pedestal fan, you often go and clean it and touch it. So if it is leaky, then you get a shock, you get electric shock. So if that body of if the motor of the fan is grounded, then you don't feel that shock, because the leakage current flows to the ground through the ground. Okay. Now, one more thing you have to understand. So in the distribution box, after the meter board inside the house, there will be a box. You can see so many switches are connected there. They are called DP switches, dipole switches. Dipole switches. Dipole switches, which sometimes they are automatic. Automatic dipole switches are called miniature circuit breakers, MCB. Miniature circuit breaker. So many miniature circuit breakers you can see in the distribution box. What for? These circuit breakers are used. Here I have shown only one. Okay. So you go home in the evening and examine your distribution box at home. You can see so many circuit breakers, miniature circuit breaker switches. Sometimes some of the circuit breakers trip. What is the reason? What is the reason for the tripping of circuit breakers? If you draw, say for example, it's a lighting circuit and the circuit breaker used is 6 ampere circuit breaker is used. 6 ampere circuit breaker is used for the lighting circuit here, and if you use more than 6 amperes of current in that circuit, that is called overloading. You are loading that circuit more than the permissible limit, and which is not good for the circuit. So the circuit breaker trips, the dipole switch come to off mode. That is called the tripping of circuit breaker. So if you draw more current from more than the permissible limit of current from a given circuit, it is called overloading the circuit. Overloading can be caused by connecting too many gadgets, too many electric gadgets above the permissible limit of the circuit. Overloading can also be caused if the live and the neutral wire come in contact. How do these two wires come in contact? The wires are insulated. Okay. So in the electrical wiring, in the electrical circuit, at points the wires may be joined. and insulation tape is put in the joint. So over the period the insulation tape may come off, or the quality of the insulation may not be that good. The insulation material deteriorate and the wires become naked and they come in contact. What happens if the phase and neutral wires come in contact? Now look here, this is my home and this is my school. I have to go like this and reach the school. This is the path. This is the usual path, road, through which I have to travel and reach the school. Instead, so here I have so many troubles here. Road humps are there, circles are there, sometimes traffic jam will be there. It is not that easy to reach the school through this road. I have a shortcut here. A shortcut. No humps, no troubles here. Straight away I can reach. The only thing, the road is a little narrow. I can reach here. This is the shortcut. This is the normal path. This is a shortcut. So in the normal path of the circuit, so many devices are connected here. No problem. If the phase and neutral wire come in contact, that is a shortcut. Current from the phase without going through the devices straight away come to the neutral. Shortcut. Excess of current, no resistance at all, no devices. So it is a least resistance circuit. Excess of current flows through the circuit. Overloading. It is called short circuit. So what is a short circuit? If the phase and neutral wire come in contact, it forms a least resistance short path for the current. That is a short circuit. The excess of current flows through the circuit. If you have protective devices like circuit breakers, the concerned circuit breaker trips. If there is no circuit breaker, it is loose, then the excess of current flows through the circuit. You get a short circuit fire accident. The wires get heated and it starts burning. You might have read in the newspaper or you might have watched in the TV about short circuit fire. This is how short circuit fire is caused. So to avoid a short circuit accident, suitable miniature circuit breakers should be used in the respective circuits. For lighting circuit, the miniature circuit breaker may be of 6 ampere. For heating circuit, it may be more than 10 ampere. More than 10 ampere circuit breakers are used for heating circuits. 6 ampere circuit breakers are used for lighting circuits. So these are the things you have to understand and keep it in your mind regarding domestic electric wiring. And if you have any doubt, you can ask me. If you have any doubt regarding this electrical wiring, domestic electric circuit, you can ask. So that's all, children. Now I'll give you some homework. What is the potential difference between live and neutral wire in domestic circuit? Electric potential at the neutral point is 0. Why? How is a short circuit caused? What is overloading? Explain the function of earth wire. So, had you listened to my class, then you don't find any difficulty in answering these questions. You have your textbook, you can also refer it and answer these questions beautifully. If you have any doubt regarding electricity lesson, you contact me. That's all. Thank you very much for watching. Wish you all the best.